Hey everyone, this is Alex from wornoffkeys.com and welcome to my complete JavaScript course. This is a 1-hour preview of what the full course has to offer, and if you're new to JavaScript or new to programming in general, this is the perfect place to start. So if you find this introduction video helpful, consider checking out the full course with a link down in the description. I'll explain more information on the course later on, but for now, let's just dive in and start learning JavaScript. Before we can learn JavaScript, we need a place where we can actually write and run our code. To do this, we could download a text editor specifically designed for programming called Visual Studio Code. So I'm going to go into Google and I'll type in Visual Studio Code download. Then we can click on the top link. And I'm on Windows, so I'll select the Windows download here. I can go ahead and click on Keep, and then I can open this up. Now we can go through the installing process. I can start off by accepting their license agreement. Then I can click on Next, and most of the defaults can be kept the same, so I'll just click on Next a couple times. And here, you can create a desktop icon if you want. However, I won't do that. Then I'll click on Next, and then finally Install. Ensuring that this checkbox is checked, we can then click on Finish, and VS Code will go ahead and open up. We have this untitled document here. We can go ahead and close out of that. And at the top left, we see this icon, which will open up the File Explorer. This will show all the files and folders within our workspace. And I'm going to go ahead and bring Windows Explorer onto here. I am within a courses folder, and I'm going to make a new folder called JavaScript. You can use whatever folder you want, and it can be located wherever you want. But once you create it, you can click and drag it into your workspace over here, and VS Code will automatically refresh, and it would then list all files and folders within that folder if there were any, but of course, we just created ours, so we don't have anything here. Now, VS Code is basically ready to use, but we have one more thing to do. If I click on these 4 boxes right here, we could then search for an extension that's going to help make our lives a lot easier moving forward throughout this course. The extension is called Live Server. And if we click on the top results, it should have a logo like this and around 10 million downloads. We can then click on Install. And that's everything we need to do to move forward and actually learn how to write JavaScript. We are now finally ready to start writing our very first JavaScript program. I'm within VS Code, and I can use this icon here at the top left to create a new file within my workspace. I'm going to do that, and I'm going to name this index.html. Now, HTML is a markup language that is used in websites, but you don't need to know HTML to go through this course because we're largely going to be ignoring it. However, it is necessary in order to use JavaScript in the way we'll be learning throughout this course. We can also make another new file called index.js, and this is our actual JavaScript file where we will be writing our JavaScript code, and our index.html file is largely used just to run our JavaScript code. Within VS Code, it gives us the option to get started with HTML very easily by simply adding an exclamation point and then pressing enter. This is going to give you this basic boilerplate of HTML code that we can then add onto. And to make sure everything is working, I can go ahead and save this. Then I can right click on my index.html and I can click on Open with Live Server, or you can use the shortcut on your screen there. So now this will open up in my web browser, and here we see this document line as the title. If I minimize this again, and I change this document to test or any other text, and we save it, going back into Chrome, we see that this is changed automatically. So what Live Server will do is it will run our code within our web browser, but it'll also automatically refresh our web browser whenever we change our code, which is very convenient for us. So I'm going to set up my window like this, where I have my Chrome browser on the right here, and I have Visual Studio Code on the left. And I'm also going to zoom in so you're able to see everything. Now, there's very little changes we have to make to this HTML code, but the first thing we have to do is import our index.js file within our HTML code. So within the body tags here, which should be line 10, we can add in a script tag, and VS Code should automatically add in the closing script tag with a / here. If not, then just go ahead and add it in yourself. And within this script tag, we can then add in a source, which is going to be where the file is actually located. We say source equals and then quotes, and VS Code automatically has this dropdown where we can select different files that are within our workspace. So we want to select index.js and then save this file. We can now close this. We can also minimize our Explorer here because we don't need to see all the files. This gives us much more room to write our code. Now within Google Chrome, we can use F12 to open up our developer tools on the bottom. And if you don't have a dark mode already enabled and you want one, you can click on the gear icon near the top right. Then under Preferences and Appearance, the theme can be changed to dark, and then you'll get a dark theme like this. You also want to ensure that you are within your console tab. This is where we will see the output of our JavaScript code for the time being. So I'm going to zoom in and make sure that this takes up more of the window because we're not going to actually display anything on the website as of now. Going back into VS Code, we can actually start writing our very first program, and we should see the output of that program or the result of that program down here on the bottom right in our console. So I can go ahead and type out console.log and add in a parenthesis, and a closing parenthesis should automatically be added. And in between, we can add in double quotes, and similar to the parentheses, a closing double quote should automatically be added. Whatever we type inside the quotes is considered a string, and this is basically a sentence or a collection of characters. And this is the text we want to log to the console. So I can say hello world, and then I can add in a semicolon at the end. And this is basically a way to end this JavaScript statement, similar to how a period ends a sentence in English. I can then save this, and we automatically see hello world in the console right here. I can then change this text. Let's say I add in a couple exclamation points, and when I save it, we automatically see it refresh over here with the changes. So congratulations, you just made your very first JavaScript program. And while this may not seem like much, as we move forward throughout the course, you're going to learn a lot more about the JavaScript programming language so you can write your own software and your own websites. When writing our JavaScript code, we can't just write anything we want into our file. For example, if I were to add in some text here, VS Code will automatically understand that this is not proper JavaScript and will underline it in red. If we want to add in notes, or what is properly known as comments, we can prefix the entire line with 2 forward slashes. Actually, VS Code has a shortcut for this, where on Windows you can hold Control and press forward slash, and on Mac it is Command forward slash, and it will toggle this line to be commented or uncommented. You can even have multi-line comments. So if I add in some text here, I can start a multi-line comment with forward slash star, and I can then end the multi-line comment with star forward slash. Alternatively, you can use the shortcut in VS Code. However, this will just toggle a bunch of single line comments, but in this exact case, because we have a shortcut and any lines we're highlighting can be toggled, it won't actually make a difference. Now you want to keep in mind that comments should be used sparingly and only when necessary. That's because your code should be self-explanatory where comments aren't needed, but oftentimes with confusing code, comments are useful when looking back at some old code of yours or when working with coworkers to let everyone know what is happening. So for example, if I go back to the previous console log statement that we previously saw, I should not add in a comment here that says prints hello world because the code is self-explanatory. It's obvious what it does, and so a comment should not be used here. Throughout this course, I'll be using comments from time to time, so you should get a good idea of when and where to use comments correctly. We're now going to talk about variables, which is arguably the most important concept behind any programming language. That's because variables help us store and access information within our programs. So I'm going to go ahead and create a variable. I encourage you to code alongside me, and then I'll explain what each part of this code does afterwards. Let's start off by saying let age equals 27 semicolon. And of course, you can change the 27 to whatever your age is if it's different. So let's talk about this let keyword. This is going to tell JavaScript that we are creating a variable. And immediately afterwards, it will expect the variable name, which we provide here as age. Keep in mind that there are some rules and common conventions for naming your variables, which I'll cover later on in this video. Next, we have an equal sign, which is an assignment operator. This will take the value to the right of the assignment operator, in this case 27, and assign it into the variable on the left, in this case age. Afterwards, of course, we have our number, and this could be a string or other variable types, which we'll cover later on in this module. And then, as usual, we have our semicolon at the end. So what can we do with this? In the Hello World video, we'll use console.log to print some text to the console. We can do that here and print the contents of this variable. So for example, if I say console.log age without any quotes, and I save this, we now see 27 in the console. If I were to add in quotes here, and I save it, we now see the word age. That's because we are now passing in a string to the console.log. If we don't have any quotes, it will then understand that we are passing in the name of a variable, and so it will try and retrieve the value that's associated with that variable. We can also change the value inside the variable. So let's say that I just had a birthday. I can now say age equals 28. Now if I save this, we see 28 in the console and 27 is nowhere in the console. That's because the previous 27 value from line 1 is replaced from line 3. You might also notice that we are not using the let keyword here. That's because let is only used when creating a variable, not when reassigning a new value. So now let's talk about variable names and what we can and cannot do. The first thing I want to mention is how to rename variables in a convenient way throughout VS Code. So here we have 3 usages of the age name. If we click on the declaration of the variable, which is where we're creating it, and we press F2, we can now rename this in all use cases. So if I say my current age, spelled exactly like this, it will now rename it throughout the entire code file, which is very convenient for us. And you might be wondering why I named this with a capitalization like this. Well, this is something called camel case notation. And this means that the first letter of the first word, in this case M in my, is lowercase. But the first letter of every other word, C in current and A in age, are uppercase. This makes it easier to read when there's multiple words in a variable name because variable names cannot have spaces. If I were to add in spaces here, VS Code automatically complains because this is not correct JavaScript. So using camel case notation makes it easier to read when there's multiple words squished together in one. There's also some things we cannot do with our variable names. For example, it cannot start with a number. VS Code will automatically complain because, again, this is not proper JavaScript. We also cannot use JavaScript reserved keywords as our variable names. So for example, let here is a darker blue than the rest of the code. That's because this is a reserved keyword and we cannot use it as our variable name. For example, if I rename this to let, and then I save this, we get an error in the console saying that let is disallowed as a lexically bound name. Now, I'll get into the exact details of the wording there in a future video in this course, but just know that this means we cannot use this as a variable name, so I can use Control-Z to undo that. A final note on variable names is that they should be descriptive and meaningful. Sometimes I see developers name their age variable A because it's shorter and easier to type. However, this makes it harder to read the code, especially if you're in a working environment with coworkers, but even if you're just programming alone, if you review some code from a few weeks ago, you might be confused what's happening, and that confusion could be quickly solved by having a meaningful variable name. Now, in this exact use case, my current age is probably overkill. We could have age, and that's probably a meaningful name. We could also do something like user's age, and other things like that are good enough. And throughout this course, as we continue to make our own projects and learn more about JavaScript, you'll learn the proper ways to name your variables to create a meaningful name. In the last video, we covered variables and we created an age variable similar to this one. In this video, we're going to be covering constants, which are basically variables that cannot change. They are created using a different keyword. So instead of let, I can use const, which is short for constant. And this will typically act as a normal variable in most use cases. For example, I can still console log this, and we now see 27 in the console. But what a constant means is that it is a constant value. It cannot change. So if I try to reassign a new value here, for example, if I had a birthday again, I now get an error in the console saying assignment to constant variable. And when explaining this concept to someone who's new, they often ask the question, well, why don't you just not change the variable? And the reason is that constant forces this variable to never change. So that means if you want a variable to never change, and you're in a somewhat large project or working with coworkers, an error will pop up when developing, such as the error we see in our console, if that variable is changed. That lets you know in the future, or your coworkers know, that this variable is not intended to be changed, and then they can look into why, often because variables should not change unless necessary, and in some cases will cause breaking bugs within your applications. This leads to more predictable code where you understand when things can and cannot change. And to add on to that, it's actually a best practice to always use const unless you specifically know your variable will change. So in the example of age, if I were to get rid of this, the age is never changing within our program, and so we should use const here. However, if we know this variable will change, of course, we have to use let. And a final note is that there is another way to declare a variable, and that is using the var keyword. Now, there are some complexities with this keyword, and I would highly encourage you not to use it. However, if you are learning JavaScript elsewhere as well, and you come across this keyword, this is another way to create a variable. The exact details of this keyword and why you shouldn't use it will be described later on in the course. But for now, just strictly stick to using const or let. I hope you're finding this introduction video helpful. I want to quickly show you 5 things you're going to get with the complete course. The first of which is a complete understanding of JavaScript fundamentals, even if you're new, and that's something that I can't teach within a 1-hour-long video. Next, I want to mention that you're not alone when learning JavaScript. The course comes with student support, so you can ask questions and get any help you need. And an important part about the course is teaching you how to think like a programmer, so you can make projects without the need of following a tutorial. And going off of that, you're going to learn how to build multiple real-world projects. And finally, once you're done with the course, I'm going to show you which direction you should go in depending on your interests and goals as a programmer. That way you're not feeling lost after you're done with the course. So if these benefits are interesting to you, check out the complete course at the top link in the description down below. With that said, let's get back to learning JavaScript. We're now going to cover the different variable types we have access to and this potential use cases. So we've already covered the number variable type, and I can say let number equals 50. And this is something we've already worked with in previous videos. The value here is just simply the number without any special attributes such as quotes. However, there are other types of variables. We've briefly mentioned strings, but we've not seen them in a variable yet. So here we have a string. I can say let name equals Alex. Of course, you can add in your own name. And now we have a string variable. We can use this just like any other variable. For example, we can console log name. If I save this, we now see Alex in the console. If there's a line going through your name here, don't worry about it. It's just a VS Code thing. It doesn't actually matter. And because we are declaring these variables with let, we can change these variables. For example, I could say name equals Alexander. I can then save this, and now we see the new name in our console log. So I'm going to get rid of these two. And now we can move on to a new type of variable that we have not seen yet, called a Boolean. And I encourage you to add in these comments as well, because it will help you remember these concepts moving forward. A Boolean is a special type of variable that can hold true or false. So let's say let is programming equals true. If I log this to the console, and in this case, this word is long, so I can press Control and space to open up this menu and press Enter to autocomplete. We now see true in the console. Alternatively, we can also have this be a false value, and now we see false in the console. Booleans are commonly used within conditional statements, which is something we'll cover in a few modules. Next up, we have undefined, which is both a value and a type. That's one of the nuances of JavaScript, is that undefined acts in a slightly strange way compared to most other programming languages. This is actually the default value that's given to a variable. So if I say let some variable, and I don't assign a value, I just end the line with a semicolon, I can then console log this some variable. If I save this, we now see undefined in the console. Now, if I comment this out and I save it, we get an error saying that some variable is not defined. This is another one of the nuances in JavaScript. Not defined is different than undefined. Undefined is a value that is assigned to all variables by default, where the not defined error means that what we're trying to access here never existed in the first place, because this is never actually ran as JavaScript code. It's the same thing as us deleting it. And if I run this, we still get the same error. So if I undo this and I save it again, we are creating a variable. However, this is basically me saying equals undefined. And typically, you never want to manually assign the undefined value. It is a bad practice because undefined is meant to represent something that we as programmers have not used yet. We have not assigned a value to in any way. However, for demonstration purposes, if I save this, we see the same thing in the console. So real quick, I'm going to delete this because we should never manually assign undefined. Now the next one will be null, which is similar to undefined, but this is what we would use if we want to manually assign a null value. So I can say let some other variable equals null, and then I can console log this. So console log some other variable. I can save this, and here we see null in the console. So null is what you should use if you specifically want to assign no value to your variable. And again, you should never manually assign undefined. Instead, assign null, because that makes it very clear to yourself or to other developers that are working on the same project that this is something you specifically want to be no value. So I'm going to delete this again. And there are a few other types of variables, but these are things we're mostly going to be focusing on later on throughout the course. For example, we have symbol, we have big int, we have object, and we have function. I would encourage you not to look into these on your own because they are fairly complicated, at least some of them are, and there are entire modules dedicated to some of these. The only reason I mention them is so if you do run into them, you are aware that these are additional variable types, but we'll be covering these later on in the course. For the most part, you'll be using these variable types here as they cover almost every use case that you're going to run into at this stage in the course. We're now going to talk about various arithmetic operators, which are ways that we can use to manipulate number variables. Let's go ahead and create a number variable. I can say let, because this variable will be changed, number, you can use any name you want, equals 50, and you can use whatever value you want. I can go ahead and add in a console log for number, just to make sure everything is working okay. Saving this, we see 50 in the console, so everything is good to go. Now we're going to go ahead and try increasing this number. So I can say number equals number plus 10. We've learned about the assignment operator before. It will take the value to the right of the equal sign and assign it into the variable on the left. In this case, the value is the result of this equation, number plus 10. So JavaScript will grab the value of the number variable and then add 10 to it, essentially creating this. So then number should equal 60. We can prove this by saving our file and seeing 60 in the console like so. This will also work with subtraction. Here we see 40, and multiplication. Here we see 500, and division, which is a /. Here we see 5. Let's go ahead and add in comments that describe those. That way you have an easier time remembering things moving forward. So I can say plus equals add, minus equals subtract, star equals multiply, and / equals divide. There's also a fifth option, which is called modulus, and that is a percent sign. So let's add in modulus, and this is going to be the remainder of a division. So to prove this, we can use number modulus 10. If I save this, we see 0. And that's because there is no remainder when dividing these two numbers. This is often used to see if a number is even or not. So I'm going to go ahead and comment this out for now. And I'm going to create a constant because this variable will not change. And I'm going to call this is even. And I'm going to assign this equal to a comparison. A comparison is something we have not learned yet, and we'll dive into further detail in the future videos. But for now, I'll give a brief explanation. So we can say number modulus 2, 3 equal signs 0. There are a couple different ways to compare things in JavaScript, and this is one of them. Basically, it will take the thing to the left and compare it to the thing on the right. And this will result in a Boolean value, which we've learned before is either true or false. To prove this, I can console log is even instead of number. If I save this, we now see true in the console. So that means that this is a even value. If I change 50 to 51, we will now see false in the console because 51 is not even. So this is an example of the modulus operator in action. I'm going to go ahead and delete these and set our number back to 50. And we can now look at compound assignment operators, which are a quicker way of doing some of the previous calculations we had. For example, we had number equals number plus 10. And this gets kind of tedious to write out. So using compound assignment operators, we can do this in a quicker way. I'm going to comment out line 9. And here on line 12, I can say number plus equal 10. Line 9 and line 12 do the exact same thing. To prove this, I can add in a console log for number. Then I can save the file and we see 60 in the console. We can also use the same concepts here within these compound assignment operators. For example, subtraction, multiplication, and so on. So this will actually change the value within the variable. I can now comment this out, and I'm going to move this console log to the bottom of the file. We can now talk about incrementing and decrementing, which is how we increase or decrease a number by 1. Because if we just do number plus equal to 1, while this is slightly quick to do, there is a faster way when it comes to incrementing and decrementing because they are so frequently used within JavaScript. So I'm going to comment this out, and I can say number plus plus. Lines 15 and 16 do the exact same thing. If I save this, we now see 51 in the console. We can even put the two pluses on the left side of the variable name, and this will give us the same exact result in this exact use case. However, these two operations act slightly differently. Where you place the pluses will change when the number is increased. This is more clear if I add in the pluses into our console log. So if I put the pluses here, it will first increase the number and then use it. In this case, it will use it in our console log. So if I save this, we still see 51. But if I add those pluses to the end, it will first use the number in our console log and then increase it. To prove this, if I save it, we now see 50 in the console. However, in memory, our number variable holds the value 51. We're just not using it after the increment, so we don't see that. To prove this, I can add in a console log, and we can log out the number variable. So at first we see 50 because that's our initial value, and we're logging it to the console here. And after we've logged it, we are then incrementing it or increasing by 1. Then line 18 comes around and prints the current value after we've incremented it. And that's why we see the 51 here. Now, if I add in the two pluses previously to this, what do you think the output in the console will be for these two console logs? Well, if I save this, we now see 51 twice, because on line 17, we are first incrementing number, bringing it to the value 51, and then using it in our console log. Then on line 18, we are console logging number, and there's been no manipulation of that variable since line 17, so it's the same value. And That's how we see 51 twice. When programming, you may want to get the type of value that a variable holds dynamically, and we can do this with the type of operator. So let's say we have a number with let example equals 50. We could then gain what type of value this variable holds within a console log, for example, by doing console.log. Then we can use the type of operator within the parentheses. So we can say type of one word. We notice that this becomes a darker blue, the same blue as the let keyword, because this is a JavaScript reserved keyword. Directly afterwards, we can specify the name of the variable, in this case, example. Now, if I save this, we see number in our console because this variable holds a number type. If I were to change this to a string and I save it, we now see string in the console. That's because obviously this variable now holds a string type. Now, this isn't the most commonly used thing within JavaScript. However, every now and again, it will be useful, so it is important to be aware of it. We're now going to talk about how to convert variables from a string type into a number type. Let's say that we're making a website and we're receiving input from the user, which is something that we'll cover later on in this course. That input that the user enters is always in the string format, because of course they can enter whatever they want. Let's say it's an email field. And let's say that we want to access those pieces of information as a number because we're asking for their age in a hypothetical example. Well, I could say const age equals 27 in quotes, because in a real example, we are going to receive the input from the user as a string. We can now use console.log with type of age to see what the type is. And of course, we see string in the console on the right, because obviously there's quotes around it. But what happens if I want to convert this into a number? Well, I could say const example equals parse int with a capital I. We could then pass in age. Now I could print out type of example. And if I save this, we now see number in the console. I'm going to go ahead and copy and paste the console log and then remove the type of operator so we can also see the value, which is 27, as we see in the console. So what is parse int? Well, this is called a function, and we've actually been using a function this entire time in the form of console.log. Now, functions are a huge part of JavaScript. In fact, we have an entire module about them within this course, but for now, we're not going to dive into the details. Just be aware that it sometimes receives some input that goes within the parentheses, and it returns some output, which we can use with an assignment operator to put into a variable, in this case, example. And each function does its own thing. The goal of any function is to do some kind of processing to achieve a specific goal. In the exact case of parse int, it is going to convert a string, which we pass in within the parentheses, into a number, which is then returned into this variable. And that's how we see the number 27 within the console. Now, there's also another way we can do this. So if I comment this out, I'm going to then add a new comment called the unary plus operator. I can then say const example equals plus age. There's a single plus sign to the left of the variable name. If I save this, we now see number within the console. This is basically the same thing as parse int. However, parse int is safer to use because let's say that the user inputted some information that is not a number. For example, they entered 27 test into our hypothetical website input. If I save this, we now see a number type, but the value is NaN. So I'm going to add in a comment at the top of our code. I encourage you to do the same. NaN equals not a number. And ironically, this still has the number type. Now, if I comment line 8 out here, where we're using the unary plus operator, and I uncomment the parse int and I save it, we now see 27. So the function of parse int is going to do more than just convert a string into a number. It will also remove all non-number characters. And you might immediately think, well, why not just always use parse int if it's going to make our lives easier? There is a use case where you can compare the value in example against not a number. And comparing things is something we'll cover in a future module. But hypothetically, if we see that example would become not a number, we can then provide some meaningful input to the user on our website, asking them to only enter a number. So both have their use cases, and it's important to understand how they differ. Over the next few videos, starting with this one, we're going to be talking about errors within JavaScript. We're going to be covering topics such as how to read the error message effectively to understand what's wrong and where. And in the next video, we'll be covering how to actually create, or technically known as throw, your own errors. That way, other people using your code or yourself will know that something is wrong. And then the video after that, we'll cover how to handle any errors that are actually thrown. So let's start off by defining 3 different types of errors within JavaScript. The first one is actually one we've seen before, and that is going to be a syntax error. And a syntax error is only something that is occurring within your actual text editor, such as VS Code. So for example, if I create a variable called const a number equals 50, we now see this underlined in red because this is not proper JavaScript, and this is technically a syntax error. These are things that you'll see before your program actually runs, and they're easy to spot because VS Code automatically understands where they are. So an obvious simple solution to this is to remove the space. That way we only have a single word as our variable name. Now next up, we're going to have a runtime error, which occurs whenever the program is running, of course. So for example, I can try console logging a variable that does not exist. So console.log test. And obviously, we do not have a test variable. So if I save this, we get this red message in the console that says uncaught reference error. Now, the reference error is a type of error this is, because we are trying to reference this variable, but it doesn't exist. And the term uncaught is important, and you'll learn why that's important in the video after next when we're trying to handle, or what's properly known as catching, an error. After that, it says some details such as test is not defined, and we can obviously see that here. But what's most important is that this tells us where exactly this error is. It says index.js line 5. And of course, we see here we are in our index.js file and on line 5. We can also click on this, and it will then open up a different tab. I'm going to expand Chrome here. We were previously in our console tab, but now we're in sources. We see the same exact file structure right here as we do within VS Code with our HTML and our JavaScript file. So going back over to Chrome, we see the same thing here. And now we see index.js is open. And here's where the error is. Uncaught reference error, test is not defined. So not only does the error tell you what type of error it is, it also tells you exactly where the error is coming from. So you can then look at that within the Chrome browser tools here, or within your own text editor, and then get a good idea of, oh, I just forgot to define test. Let me go ahead and do that. Const test equals hello world. Now saving this, we no longer see any red within the sources tab, and within console, we no longer see any errors. So the runtime error has been fixed. I can then minimize this again. And the last error that we can cover is a logical error. This is where the program is technically working, but it's not working as expected. And this means that you made a logical error within your code, and this is probably the most common type of error. So I'm going to go ahead and create an example, and real quick, I'm going to delete these 2 lines so we don't have any extra console logs. So here we can say const number 1 equals 10 in quotes, and const number 2 equals 15 in quotes. I could then say console.log number 1 plus number 2. Now, if I save this, we see 1015. That's because we are combining, or what's properly known as concatenating, 2 strings together, and these are not represented as numerical values because they're not technically numbers, they're strings. So in this case, it is not a syntax error because there's no underlined red within VS Code, and it's not a runtime error because there is no red within the console, but it is a logical error, which means everything looks fine, but we now have to figure out why this is not working. And in such a small example, it's obvious where the problem is, but the logical errors can often get very tricky because there's going to be a lot more code in a real project, and you have to track down exactly where it went wrong. Once we dive into building actual projects later on in this course, you'll get a good idea of how to find and debug logical errors. I hope you're finding this introduction video helpful. I want to quickly show you 5 things you're going to get with the complete course. The first of which is a complete understanding of JavaScript fundamentals, even if you're new, and that's something that I can't teach within a 1 hour long video. Next, I want to mention that you're not alone when learning JavaScript. The course comes with student support, so you can ask questions and get any help you need. And an important part about the course is teaching you how to think like a programmer, so you can make projects without the need of following a tutorial. And going off of that, you're going to learn how to build multiple real-world projects. And finally, once you're done with the course, I'm going to show you which direction you should go in depending on your interests and goals as a programmer. That way you're not feeling lost after you're done with the course. So if these benefits are interesting to you, check out the complete course at the top link in the description down below. With that said, let's get back to learning JavaScript. We're now going to cover how to actually create, or what's properly known as throw, your own errors. And you might be wondering, why would you want to do this? Well, sometimes something can go wrong where you want the program to crash, so you know as a developer that you should fix that. Or, as we'll learn in the next video, you'll want the handler of the error to then execute its logic, so then you can handle the proper error correctly. And in order to throw an error, it's actually very simple. Now, there are some new keywords you're going to learn here, and I'll be covering the exact details of what those do in a future video. So for now, if you don't fully understand everything that's happening here, that's fine. Just be aware that this is how you throw your own errors. So let's go ahead and create a new error. We can do that by saying throw new error with a capital E, parentheses, and then a string. Within here, we can add in anything we want. If I save this, we now see an error in the console. It just says uncaught error, anything we want. And it says where it is in the code, which is index.js line 3. And of course, we can still click on this to open it up within the Chrome browser, as we see right here. So exactly when and where we should throw our own errors will become more apparent once we start building our own projects later on throughout the course. We're now going to talk about how we can handle, or what's properly known as catch, any errors that occur. What we're going to be technically learning is how to use a try catch block. And we'll also be learning about finally, which is optional and sometimes adds on to this functionality. So what is try catch? Well, let's go ahead and write out the basic syntax, and then I'll explain what each part does. We can say try, opening curly brace, and then at the end of the ending curly brace, we can say catch with a parenthesis, and here we have access to a variable, which is often named E, but I like to name this error because it's more descriptive. We then have another curly brace here. So what's actually happening here? The try code will be ran, and if any error occurs in here, then the catch code will then be ran. So let's go ahead and try creating our own console log referencing an undefined variable. So console.log test. Now, if I save this, we see no errors in the console. And that's because we are catching the error, and then we have access to it here, and then we are not doing anything with it. We have to specifically log it to the console if that's something we want to do. Otherwise, JavaScript will take no action here. Let's go ahead and try doing just that. Console.log error. Now, if I save this, we do not see a red message in the console, but rather just a normal message that has access to all the information we need. But why is it not red? Well, that's because in order to make it red, we have to use console.error. And there are a few other console options, but those will be covered later on in the course once we need to know those. If I save this, we now see the message in red. It says test is not defined. It gives us a line number, which is 6, which is precisely where the error is. And of course, clicking on this would open it in the Chrome browser tools. We also have access to just the message if we wanted. So I'm going to go back to a console log here instead of console.error. And instead of just passing in error, I'm going to pass in error.message. Now, the exact details of what the dot does here will be covered in a future module. It's too complicated to explain right now. So let's go ahead and save this. And now we see test is not defined, which is the message that was attached to this error. So now let's cover the finally portion. So let's say finally, we can now add in a console log saying finally was ran. If I save this, it now says test is not defined, finally was ran. Now let's say I go ahead and I comment this out so there is no error, in which case the catch block, which is these two curly braces right here, will not be ran. But if I save this, we still see finally was ran. So finally is always ran no matter if there's an error or not. And try is ran until an error occurs. So to explain this further, I can add in a console log printing out the number 1. Then I can uncomment this line where the error would occur, and I can then add in another console log printing out the number 2. If I save this, we see 1, test is not defined because this threw an error. At that time, the code execution is interrupted and the error is thrown, which then means our catch block is executed, which then gives us the console log of the message. And then finally is always ran. So we then see finally was ran at the bottom as the third console log. So now let's go ahead and have a quick test of your understanding. I'm going to comment out where the error is and pause this video and take a few seconds to think about what will be printed into the console with the current code. So if I save this, we see 1, 2, and then finally was ran. Line 10 is never ran because there is no error within the try block. Of course, 1 and 2 is printed because those are just standard console logs. And as we know, finally is always ran. So we see finally was ran as the last line in the console. And you might be wondering, why would you ever use code like this? Well, something that we're not going to be diving into within this course is database connections. Sometimes you might attempt to do something with a database, perhaps insert some data or read some data from the database within your try block here. And that oftentimes can have some errors depending if there's an invalid connection or other things like that. In which case, you can handle those errors, and then finally, you can close that database connection. This is one real-life example of where try, catch, finally will be useful. In a similar concept, this is often useful if you're going to be accessing stuff from a file. So you can try to open that file and then read some contents from it. And if something goes wrong, then we could handle it if there is an error thrown. But finally, we can go ahead and close that file. We're now going to talk about functions or methods as well as properties. So throughout the course so far, and especially moving forward, we've often used parentheses. For example, with console.log, parenthesis, and then we can print out anything we want here. Well, what are these parentheses and when should you or should you not use them? Well, the parentheses are used whenever we're working with a function. And again, a method is very similar. The exact difference will be explained later on in the course, but for now, just think of them as the same thing. So the parentheses are used to pass any type of information we need into that function. That function might use that to then perform some type of action. In this case, console.log will simply print the given information to the console. If we save this, we now see hello world in the console. We can also add in multiple strings of text. So if I save this, we now see hello world space test. Now pieces of information being passed into a function are known as arguments. And each function will have different arguments. Some may even have none. That depends on each function's use case and what information it needs to perform its task. Functions can also return pieces of information. So for example, instead of printing out these strings here, I can print out parse int with parentheses because this is also another function. We can pass in a string of 1, 2, 3. And if I save this, we then see the number 1, 2, 3. To prove this, we can use typeof. And if I save this, we now see the type is number, even though we gave it a string. And that's the purpose of the parse int function. It will take in a string and convert it to a number and then return that number. This is something we've already covered, but this also shows that functions can return pieces of information, but they don't always have to. Similar to the arguments here, some functions require them, other functions may not, and it's the same concept for returning information. Some functions might not return anything. But the takeaway here is whenever you see these parentheses, that means we are interacting with a function or a method. Now, one more thing I want to show you is properties, which is when we don't use the parentheses. So let's say console.log, and instead of type of parse int, I say math.py. The m and the pi are uppercase. And if I save this, we now see the approximate value of pi. This math object here is something we'll be diving into in the next video, but this is known as a property. We do not have any parentheses around it because it is not a function or a method. A property is something that is attached to something else, in this case math, and has some information that we can just read. So to recap on properties, they are basically just a variable that is attached to something else. And if any of these concepts are confusing, don't worry. As we move forward in the course, we'll be creating our own functions and our own properties, and things should make a lot more sense then. JavaScript offers some basic math functions that we can use. We'll be diving into a couple of those within this video, the first of which is called ceil, which is short for ceiling, and this will round a decimal number up to the nearest whole number. So for example, I can say console.log parentheses math with a capital M dot ceil parentheses, and then we can enter in a decimal number such as 2.48 or anything else. That's just a random number. We can then go ahead and save this, and we now see 3 in our console. If this was 2.1, it will still round up. The next is going to be floor, which is similar, but it will round a decimal number down to the nearest whole number. So let's add in a console log again. Math with a capital M dot floor, we can pass in 2.9. If I save this, we see 2 in the console, because 2.9 rounded down to this nearest whole number is of course 2. So these are often useful if we want to convert a decimal number into some form of whole number. Next, we're going to take a look at random numbers. So I'm going to go ahead and say const result equals math, again with a capital M, dot random. Add in the parentheses, and then I can use a console log to print this to our console. So console log result. If I save this, we now see a random number between 0 and 1. If I keep saving this, we'll get a different number every single time. But you might be wondering, why is it just between 0 and 1? And why can't we just have whole numbers? Well, there's simple ways to fix this. I'm going to create another constant here called max and set this equal to 10. This will be the maximum number we can get from this. We can then multiply math.random times max. So if I now save this, we're going to get a random number between 0 and 9. So 0 and 9 isn't exactly 1 through 10, so we can simply add 1 afterwards, and the multiplication will be done first, and then it will add 1 afterwards. So if I save this, we're now going to get a random number between 1 and 10. But we still have decimals here. Well, we can use math.floor to fix this problem. I'm going to highlight everything right here, and I'm going to use Control X or Command X on a Mac to cut this text. I can then use math.floor, parentheses, and then Control V or Command V to paste the text back in. I can then save this, and we'll now get a random number between 1 and 10. I'm going to comment this out. And the last basic function we're going to look at is for getting the absolute value of a number. So an absolute value is the distance between that number and 0. So the absolute value of 10 is 10, and the absolute value of negative 10 is also 10. This effectively converts a negative number into a positive number and doesn't affect any positive numbers. So if you want to ensure that a number is positive, you can then use the absolute value method. So to do this, I can say console.log math.abs, which stands for absolute value. I can add in parentheses and then any type of number. So for example, 10, if I save this, we now see 10. But if I add in negative 10 and I save it, we still see positive 10. So this is useful to convert any number into the positive version of that number. Now, JavaScript offers a lot more functionality with this math object we've been using. And if you Google JavaScript math and click on the first link, you'll see additional information. For example, here's static properties. These won't require the parentheses that we have been using. For example, math.pi will just use the approximate value for pi. I can demonstrate this. I can comment this out, and then I can console log math.pi, and the pi is in uppercase. If I save this, we now see the approximate value for pi. Going back and scrolling down, we see static methods. Here's ABS, which is one that we used for the absolute value. We see a bunch more. For example, here is seal, which we also covered. And if we want additional information on any of these, we can go ahead and click on them, and you'll see code examples. You can run the code examples, and you can even edit these to be what exactly you want. You can then run your edits. And this is a great way to experiment with new things. I highly encourage you go through and try out some of these, because reading documentation and understanding new parts of programming, even things outside of this course, is going to be a fundamental concept and a fundamental skill you'll need to master to be an effective programmer. When creating real websites, it's often useful to keep track of when certain actions occurred. For example, that's the way that Twitter knows whenever someone sent an exact tweet, or whenever someone uploaded a video to YouTube. One option to solve this problem is by using the built-in date functionality from JavaScript. So let's start off by creating a simple new date. I'm going to create a constant and name it now, and set it equal to a new date with a capital D. The new keyword is something we have not covered yet, and the exact details will be covered in a future video in this course. For now, just try and understand that it will create a new date, which will then give us access to certain properties and functionality to actually interact with that date, such as reading information and updating information. We can go ahead and add in a console log and see what is printed when we print out the now variable. Here we see Saturday, June 9th, 2021. It's 8:31 a.m. and it's GMT -7. Obviously, you'll have something different because you're not watching this at the exact time of me recording it, and you're probably in a different time zone as well. So there's a number of different useful functions that we can use. And similar to the last video, we'll be diving into some common use cases, and then we'll be diving into the official documentation to learn more. So let's go ahead and print out the year, the month, and the day. I'll add in some console logs here. So console.log. We can print out now, dot, and here we see a number of different functions we can use. The first one we want is the year. So we can say get full year. Add in the parentheses, and if I save this, we see 2021. I can then add in another console log with now.get month. Add in the parentheses, and we see 5. However, we're in June, which is the 6th month, so this 5 doesn't make too much sense. This is actually something weird when it comes to JavaScript dates, is that these are 0 indexed, which means that they start counting at 0, which is a common thing you see in a lot of programming languages, including JavaScript, but not necessarily when it comes to dates specifically. So basically, January would print out 0, and December would print out 11. To solve this, we can simply just add 1 inside of our console log statement, and if I save this, we now see 6. Now next up, we want to get the day, which we can do with console.log now.getDate. If we save this, we now see the 19th, which is correct with the total date that we see at the top right here. So that's how you get the date, but what about the time? I'm going to add in some more console logs here. We can say now.getHours. Going to add in a couple more. Now.getMinutes. And then we can also add in now.getSeconds. So if I save this, we see it's 8:34 in the morning and we're 12 seconds into the minute. So this is how you're going to read information from the date, but we can also take the current date and then edit this. For example, let's say we're hypothetically making a reminder app and we want to remind the user to do something in 1 hour. Well, after we create our date object and before we go to console log anything, we can say now.setHours. We can then pass in now.getHours plus 1. The parentheses are required here, just like they were in our console log down here. So currently it's 8 a.m. as we previously saw, but if I save this, we now see 9 a.m. right here and 9 in the hours right here. So we can go ahead and modify this. But why would I want to do this? Well, let's say that we now want to save this to a database or save this to the user's computer so our software can then read that later on. There's a couple ways to do this. The first is with ISO strings. The second is with a Unix timestamp. The ISO strings are more human readable, and we'll start with those. So I can say const ISO equals now.to ISO string. Keep in mind that ISO and the preceding S are all capitalized. I can now add in a console log. And for simplicity, I'm going to go ahead and comment out these 6 console logs so we don't see a bunch of numbers in our console. So I highlighted all the code, and I can use Control / or Command / on a Mac. If I save this, we now see this ISO string, which has the date, the time, and then the UTC offset. So we could store this into a database because it has the current date, time, and offset for a time zone, which means we can then convert that to any other time we need. And luckily for us, all the conversion with time zones will usually be automatic, and I'll show you how to do that here soon. But first, let's take a look at a Unix timestamp. I can say const mil, which stands for milliseconds, and I can set this equal to now.getTime. I can now console log this, so console log mil, and if I save this, we see this giant number. Obviously, this is less human readable, and you might be confused to what that even means. Well, if we take a look at the official documentation of date.getTime, we see that this is going to be the millisecond since January 1st, 1970, GMT -0. And because this is GMT -0, and most, if not all, date systems within programming will use this GMT -0 time, this creates a centralized standard that we can use to know when exactly things are. So let's go back to VS Code. And here on our console, we see the timestamp and we see the ISO string as well. Either of these can be stored into a database or into local storage, which is on the user's browser, and that's something we'll be diving into later on in the course. From there, we could then take these pieces of information and convert them back into a human readable string. Typically, I prefer to use Unix timestamps, but ISO strings are much more human readable, so I'm going to comment out the Unix timestamp, and I'm going to show you a basic example of how this works. We can then go down a line, and we're going to try and convert this ISO string into a new date. So here we created the date called now, but now I'm going to create a simple date just called date. So const date equals new date. Now when creating a date, this will by default be the current time, but we can pass in an ISO string such as this one, or a Unix timestamp such as this one inside the parentheses, and it will then create the current date that those values represent. So if I pass in ISO, this will now represent the current date. So let's scroll up and let's understand what our code does here. We're first creating a new date, which will by default be the current date and time of the user's device. So right now, that is going to be 8:41 a.m., Saturday, June 19th. Obviously, if you're following along, that would be a different time. So here on line 5, we're now increasing the hours by 1. We then have a console log, which I'm actually going to comment out to keep things easier to read. Scrolling down, we're now creating an ISO string, which creates this type of format right here from the current time. We're then creating a date, which by default, as we've already learned, will mimic the current time of the user's device. However, because we're passing in the ISO string inside the parentheses, it will instead mimic what the ISO string represents. So if I were to add in a console log for date, and again, remember, it is currently 8:42 a.m. for me. If I save this, we now see 9:42 a.m. The reason for that is because we are using the ISO string, which in theory, as I've said before, could be stored in a database or somewhere else. So if we were to load this, it then represents that one time that we stored in the database or in local storage. And so we can now read that and display that to the user. Now you might also be thinking, This isn't a very useful way to display this information to the user, and that's true. Let's go ahead and remove this console log, and let's try using a couple different built-in functions that allow to convert a date into a more readable string. So I can add in console.log date.to, and here we see some options. We've already covered isostring, but we also have a local date string, local string, and local time string. We're going to take a look at all of these. So go ahead and click on local date string, add in your parentheses, and then we can copy and paste this line twice. The middle one, I can double click here. We're going to go back and type in .to local string. And then the bottom one, we can go ahead and use to local time string. So if I save this, we first see the ISO string from line 19, but then the last three are going to be the date string from line 27. We have date and time from line 28, and then we have just the time on line 29. And this is converted into my local time. So let's say in a hypothetical situation, this ISO string is sent from New York, which is on the EST time zone. That is then stored in a database, and then my computer loads that from some application. Let's say we're reading a tweet, for example. The to local date string, the local part here is important because that will convert it to my local time zone automatically. So if they sent it at 12:43 p.m., I would still see 9:43 a.m. because that's a 3-hour difference. Obviously, that's ignoring the fact that it's actually 8 and that we're mimicking an hour difference here, but that's besides the point. So these are often useful to display information to a user. And if you want a completely custom string, you of course can build your own by using the previous methods we already looked at to get the data you want. So now if we dive over to Google, we can type in JavaScript date and click on the top results. Here we're going to see the official documentation for the JavaScript date object. Here we have a constructor, which is what happens whenever we create a new date object. The exact details of what a constructor does will be covered in a future video. We can scroll down further, and here we see getDate, which we took a look at, and that gives us the month of day. We also see getDay, which you might confuse with getDate, but this returns the day of the week. If we scroll down further, we see other things such as getTimeZone offset, getUTC hours, getUTC minutes, and there's other things you can do in here. So I encourage you to click on some of these, mess around with some of them in your code. Again, as I said in the previous video, a big skill to have as a developer is to be able to look through the documentation and figure out problems on your own. We've now completed the first module of this course, and at the end of each module in this course, there'll be a simple quiz that is optional, but you can take to test your knowledge to see what you've learned throughout that module. Attached to the description of this video is a link to sourceshare.io, and this is a custom website that I made that makes it easier for the wornoffkeys Discord community to share source code with each other. So go ahead and open that up, and you can click anywhere in this text field and use Control-A, Control-C, or Command-A, Command-C on a Mac. We can then go into VS Code and use Control-V to paste, and then go ahead and go through all the questions and see if you can figure out the answer. Try to logically think through each of the questions without actually running the code. For example, here in question 1, the question is, what is wrong with this code snippet? So you can add in your own comment here that says answer, and then type in your answer here. In the next video, I'll go over the proper solutions so you can compare those solutions to yours. So now we're going to go over the answers to the Module 1 quiz, starting with question 1, which is what is wrong with this code snippet? Well, if we go by this line by line, we're first creating a constant named age and assigning it to the value 27. We are then changing that value to 28, and then finally printing out the value within that variable. The problem here is that we are defining a constant and then immediately attempting to change the value within that constant. And as we learn within this module, constants cannot change once a value has been assigned. So line 7 here would actually throw an error. Moving on to question 2, what is the output of this code snippet? Well, first, we're declaring a variable with let named number and assigning it to the value 10. We are then printing out ++ number and then number plus plus. And as we've learned, where the two pluses are positioned near the variable name is really important. The two pluses before the variable name will first increase that variable and then use it. And then if the two pluses are afterwards, it will use that variable's value and then increase it. So here we're starting with 10, and then we're going to increase it to 11 and then print it. So on line 14, we would see 11 in the console. On line 15, we are going to print number, which is still currently 11, so we would see 11 twice, and then we are increasing it. So in memory, the variable would hold 12 at this stage, but we would see 11 twice because we are not adding in any future console logs that would show the new updated value. Question 3 is what is the output of this code snippet? We're creating a constant named string, and also keep in mind that the name of the variable doesn't actually matter or have any effect on the actual contents of the variable. But this might be a kind of tricky one because it's named string and we have a string of numbers here. We are then printing out the type of string. But the tricky part comes in this unary plus operator here, which will convert a string into a number. So this variable named string will actually hold a number. And so the console log will print out the type of number rather than string. Of course, if we remove the plus here, this would definitely print out string as a type because it is a string. Moving on to question 4, which is some try catch finally, we want to see what the output of this code will be. Well, as we previously learned, we're going to try all of the code within our try block. And if an error would occur, it would then be handled within the catch block. And the finally block will always be ran no matter what. So starting with line 27, this code's perfectly fine, so we will print hello to the console. Then we are throwing our own new error here that is said, will this actually run? Which of course it will. And VS Code even makes this code right here on line 29 slightly grayed out because it won't actually run. So at this stage, this text right here will never actually be printed because our error variable that is within the parentheses. So at this stage, this text right here that says, will this actually run, will never actually be printed. The reason for that is that we are catching the error here, but we are never actually doing anything with that error. Instead, we are console logging a custom message that says an error occurred. And then we have our finally. So what would happen is we would see hello, an error occurred, and then finally. And then the text, will this actually run, and world are never actually printed to the console. Going down to question 5, this is something that I'll be writing in, and then you can compare to your own code. The question is, write the code to get a random number between 1 and 10. Well, I could first create a constant named max and set this equal to 10, which is the maximum number we want from the randomizer. Next, I can go ahead and say const random equals math.floor. And within the parentheses, we can say math.random parentheses times max plus 1. The variable random will now contain a random number between 1 and 10, and this will always be a whole number thanks to math.floor. Question 6, which is the last one, is write the code that prints the user's local time in 24 hours from now. So let's say that it is going to be 3 p.m. on the 19th. This should print out 3 p.m. on the 20th. So to do this, we could first create a variable. We could say const date equals new date. Then we can increase the hours by 24, or we can increase the date by 1. Either one of these should be fine. Because I've already covered how to increase the hours in the date video, I'm assuming most of you did that. So to demonstrate how you'd increase the date, I'm going to go ahead and use that. However, using just the hours is not incorrect at all, and is still perfectly fine to use. So here I could say date.set date. And again, this is going to be the day within the month. So I can now say date.getDate, parentheses, plus 1. If you were using hours, you'd want to use plus 24, of course. Now I can add in a console log of date.toLocalString. This will print out the local time and date for the user for the current device. So hopefully you got most of those right. If you didn't, feel free to review some of the previous videos where we covered those concepts. And if you need any help or have any additional questions within this module, of course, you can ask any questions within the course community. Thanks for watching the introduction video to my complete course on JavaScript. There's 5 key things you're going to get when you sign up for the full course. The first of which is a complete understanding of JavaScript, which goes far deeper than this introduction video has gone. You're also not alone whenever you're learning JavaScript with this course. If you ever need to ask any questions to get help, you can easily do so. There's multiple resources this course offers in order to get your questions answered. You're also going to learn how to think like a programmer, so you can stop just following tutorials and start making the apps and projects you really want to make. And speaking of that, you're going to learn how to build multiple real-world projects within the course. And finally, once you're done with the course, I'm going to point you in the right direction depending on your interests and goals as a programmer, so you can then expand further and level up your skills from there. So if you're interested in getting lifetime access to the full course, including free updates and a 30-day money-back guarantee, check out the top link in the description down below. Thanks for watching.